professor in the Department, University of Calcutta. I did my BTech and MTech in Polymer Science and Technology, then PhD in Polymer Nanotechnology. Apart from this, I am also acting as a technical director of Sir Paul South Asia Rubber and Polymer Park, West Bengal, and also I'm a qualified ISO IEC 1705/2017 Laboratory Management System implementer and internal auditor. My research careers now span over 17 years. I'm having currently 121 international publications. We have authored 7 books, 18 PhDs supervised so far, 10 more are working currently, and 1 postdoc. Now, these are the books that we have authored. All are based on our research area. That we have done research. Last year, we published this book on Sustainability, which talks about the recycling of waste plastics for creation of the profiles in sustainability. And June 2024, we published this one. This is a textbook on polymer chemistry. And this is our upcoming book. This is for the rubber industry, where we have described how finite element simulation can help in developing the rubber products with case studies. Now, coming to the topic, some facts and figures about the rubber waste. I think most of you are aware of it, but still I will mention a few points about it. Nearly 70% of the rubber waste which is produced, and that is from the tire, because most of the rubbers are consumed for making tires. So mainly the waste which is we are talking on, we refer is the tire waste. And India discusses about 275,000 tires every day as per the data from National Green Tribunal in 2023. In spite of all different ways of handling these tires, the most common is to deposit them in the landfill, resulting in a stock of scraps. Now, these tires are, this recycling of tire, mainly you can have the formation of a drum, whereby after separating the metals part, the carcass part, the rest of the rubber part is crushed under cryogenic conditions and whole diagram created. Or apart from that, you can separate the components and you can create the drum separately. And the idea is to have a combination of rubbers or definite no composition of rubbers in the drum. And apart from this, in the recycling part, we can also go for the formation of the practiced, but it's a challenge, a great challenge. Because rubber, as such, is a thermoset. It's not like plastic that it will be melted or it can be melted again. But you cannot melt rubber once the product is being made. So that is the biggest challenge, and that is why that reclaimed rubber or devulcanization, these processes require high specificity and a lot of efforts to be done behind it to get the rubber in the reusable form. And apart from that, as I mentioned that most of the waste are composed of tires, so we have different grades of tires. We have heavy duty tires, we have light duty tires, they differ in size, they differ in the amount of reinforcement being added there, amount of rubbers, and within that amount of natural rubber, synthetic rubber. So there are a lot of variations among the tire itself. And you know that all materials cannot be processed under the same conditions. So all these aspects actually poses a great challenge for recycling of the tire waste. Now, I mentioned already that you need to make it in such a way so that it can be reused. And reclamation is it's a random breakage of sulfur links and carbon main chain. So the reclaimed rubber does not have that same quality of that of a virgin rubber. And in order to retain the same quality or near about the same quality, vulcanization technique is practiced. whereby we try to selectively break the sulfur crosslinks and try to avoid the breakage of the carbon backbone or link chain. And the practice which is done in industrial scale is that using chemicals which are mainly sulfide chemicals that are used for devulcanization, but that is done at higher temperature. And when you apply higher temperature, what happens? The reaction as it is, it takes a free radical pathway. So always when you get some random breakage of the main chain, so again the devulcanized rubber that we produce, although the target is to have the same quality of that of the virgin rubber, but it eventually does not give you that. And here you see in this schematic that common process of devulcanization. One is to get sulfide chemicals, disulfide chemicals as a devulcanizer. So there you see that the